All right, so we are going to go through and find the law of cosines. So this is, we're deriving this formula. We're coming up with it, just like an ancient mathematician. Okay, the law of sines can be used to determine the measure of missing angles and sides of triangles. When the measure of two angles of a side, angle, angle, side, or angle, side, angle, or the measure of two sides in a non-included angle, side, side, angle, are known. However, the law of sines cannot be used to determine the measure of a missing angle and side of a triangle when the measures of two sides and the included angle, or side, angle, side, or the measures of three sides are known. Since the law of sines can only be used in certain situations, we need to develop another method to address the possible case. This new method is called the law of sines, the law of cosines. So if you have three sides, you can't do the law of sines. You need at least one angle to do the law of sines, okay? If you're trying to find a side and you're only given one angle, you can't use the law of sines. So you got to be able to use the law of cosines in some of these cases, okay? So we're going to look at the law of cosines here. To develop the law of cosines, begin with triangle ABC, this triangle right here, okay? From vertex C, we have the altitude drawn, that's K, and separate it into two segments, X and C minus X. Why can segments be represented this way? Why can I call this whole side C and say this is X and this is C minus X? Yeah. Right, you needed to break it up into two triangles. And if this was 5 and I took an X away, would that make more sense? This is 5 minus X and this is X. So whatever X is, this is, 5 minus less than that. The altitude separates ABC into two right triangles. Use the Pythagorean theorem to write two equations. One relating to K, B, and C minus X. And one related to A, K, and X. Okay, so we know Pythagorean theorem, these are two right triangles, right? Is A squared plus B squared equals C squared, where A and B are the legs. So if we say K squared plus C minus X squared equals B squared, that would be the Pythagorean theorem for just this side. Yep, everybody should be writing this down. Okay, and then my other side of the triangle is going to be K squared plus X squared equals A squared. Okay. Okay, now we're going to solve both equations for K squared, which means I'm going to subtract this to the other side. So I'm going to end up with K squared plus C minus X squared equals B squared, and I'm going to subtract the whole thing in parentheses, C minus X squared, to the other side. And I'm going to end up with K squared equals B squared minus C minus X squared. Now I'm going to do the other side. I'm going to have K squared plus X squared equals A squared. Shh. Miss Murphy speaking. She's actually in Mr. Juan's room. Thank you. Bye. Okay, so I'm going to subtract X squared from both sides. And I'm going to end up with K squared equals A squared minus X squared. Okay, so far I know that's a lot of letters and it looks crazy, but it should be pretty straightforward math, right? We did Pythagorean theorem, which you guys all know. And then we just subtracted to get K squared all by itself. All right. Since both of the equations in question 2 are equal to k squared, they can be set equal to each other. So we're going to make that equation. We're going to go b squared minus c minus x squared equals a squared minus x squared. All I did was both of these are equal to a squared, so I set them equal to each other. Okay, now I need to make sure you guys get that down because I need to turn the paper over. All right, now I'm going to turn it over. If everybody's got it. Okay, so the first thing I'm going to do is I've got b squared minus, hold on, if I write this down then you guys can do it, c squared equals a squared minus x squared. Okay. So that's what I'm starting with. Notice that the equation in question 3 involves x. However, x is not a side of ABC. As a result, we will attempt to rewrite the question in question 3 so it does not include x. Begin by expanding using the distributive property. Yeah. I wrote this at the very top and then I'm reading number 4. Okay. You with me, am I? Okay. We're going to expand this. C minus x squared, okay? So the first thing we're going to do is we're going to multiply this out. Do you guys remember? I like to do it this way. C negative x, and use the box. C times c is c squared. C times negative x is negative cx. C times negative x is negative cx. And negative x times negative x is a positive x squared. Or you could think of it as FOIL. First, outside, inside, last. Okay? Too small. There we go. All right? So now I have b squared minus this. Minus c squared minus 2cx plus x squared equals a squared minus x squared. Okay, I know it looks crazy because there's no numbers, but you've done stuff like this before. You've either FOILed or you've used the box. I promise you, you have. You had to do it to pass Algebra 1. Okay. Now I'm going to distribute this negative to everything. So I get b squared minus c squared plus 2cx minus x squared equals a squared minus x squared. Okay? Now I'm going to try to get all the x's on one side. Okay? The first thing I'm going to do is I'm going to add x squared to both sides. Oh, look, they go away. They're gone. Okay? So now I have b squared minus c squared plus b squared minus 2cx squared, squared, 2cx, equals a squared. Oh, no, I wrote this wrong. Sorry. B squared minus c squared plus 2cx equals a squared. Okay? Now it says it wants me to solve this equation for b squared. So I'm going to get all of these to the other side. Remember, I know this is complicated. Please write this down as I'm writing this down. I'm trying to show you that this comes from somewhere, not that you'll have to repeat this on a test or quiz. Law of sines and law of cosines you'll have to do on a test or quiz, but to derive this, you will not. So I end up with b squared equals c squared plus 2cx plus a squared. Okay? All right. This equation in question 5 still involves x. We see that x right there, right? To eliminate x from the equation, we will attempt to substitute an equivalent expression for x. we're going to write an equation involving both cosine b and x. So if we look at b, if we want to find the cosine, and we want to use b and x, so I'm back here, the cosine of b equals x over a, correct? So if I want to get x all by itself, I get a cosine b equal to x. So I get a cosine b equals x. And so wherever I see x, I want to put this. So I get b squared equals c squared plus 2a cosine b plus a squared. Okay? Now, we're going to fix this a little bit and move this around. So we're going to say b squared equals, I'm going to put a squared first, plus c squared, plus nope. This is minus, this is minus. So this needs to be minus 2 cosine AB. 2a cosine b. So this results in what looks like the law of cosines, which is what you'll be using, minus 2ab cosine b. So there are 3 ways to write this. Okay? B squared equals a squared plus c squared minus 2ab cosine b. And a squared equals b squared plus c squared minus 2 this is a c 2 bc cosine a, and c squared, which equals a squared plus b squared minus 2ab cosine c. So there's 3 different ways. What's nice is you can just plug these numbers in. So now I'm going to do an example where we're going to find a side using law of cosines. And then I'm going to do another example where we find an angle using law of cosines. Yes? There's no parentheses. It's b squared equals a squared plus c squared minus 2ac cosine b. And these are the important parts. If you missed everything else, that's the important parts because you're going to use those on your work today. Okay. Also, one of them is on the top of your homework. I strongly suggest writing the other 2 until you get used to them. So I'm going to move this. No. Yep. Okay. So we're going to write these 2 at the top of our paper. We've got the third one right there. We've got a squared equals b squared plus c squared minus 2ac cosine a. And b squared equals a squared plus c squared minus 2ac cosine b. Okay. We're going to do number 1. And as we go, we're going to write down these steps. Okay? And they start off very similar to law of sines. Okay, so I'm literally going to do 2 problems from your homework right now. So if we could focus, that would be great. First, number 1, your first step is always to label your sides. So across from C is little c, across from A is little a, across from B is little b. Okay? To determine which equation to use. Shh. Okay? So we're finding between A and B, so we're finding little c. So that means we want to use little c. Okay? Step 3. So we're going to use c squared equals a squared plus b squared minus 2ab cosine c. Okay, step 3, plug in the numbers. So we don't know what little c is. We know a is 29 squared plus b, we go 13 squared, minus 2 times 29 times 13, cosine, and c is 41. Next step, we go c squared equals, and we literally are going to put that in our calculator exactly like that. So I'm going to pull up my calculator, and I'm literally typing it in exactly as it says. 29 squared plus 13 squared minus 2 times 29, and I put it in parentheses, let's put it in parentheses. 29 times 13 cosine 41. The biggest mistakes people are making with these is not putting in the calculator correctly. So I'm literally putting this whole thing in my calculator. I'm not sure why anybody is doing anything but following along. I push enter, and I get 440.95. Now I have one more step I have to do, square root. I need to get rid of that square root in front of c. And I get c equals, I get 20.9 or 21. Questions, comments, concerns about that? Okay, so let's talk about the steps. You might want to write these down. 1, label the sides. You can write this on the back of your paper. You can write it on a separate sheet of paper. Label sides A, B, C. 2, determine which equation to use. The one that starts a squared, the one that starts b squared, or the one that starts c squared? Determine which equation to use. 3, plug in numbers. 4, put in the calculator. And 5, take the square root, and that's it. And then I am going to do number 10, and then I'm going to give you the other 8 for your homework for tonight. You can start it in class. Okay. All right. Number 10. We're looking for C. Okay. I'm going to label the sides. Little c, little a, little b. Okay, I need to use c because I'm looking for c. So I have determined that I'm using c squared equals a squared plus b squared. Sorry. Better? Minus 2. Yeah. Minus 2ab cosine c. That I'm going to plug everything in. Shh. 24 equals 29 squared. Uh-oh. I don't know what b is. So I actually first have to figure out what b is. So fun. Okay, so we have to back up. We have to go over here. We have to use b squared equals a squared plus c squared minus 2ac cosine b. We have to figure out what b is first. So, we don't know what b is. We know a is 29 squared plus 24 squared minus 2 times 29 times 24 gives us cosine 101. Okay? Nice thing about this, again, is we just plug everything on the right side of the equal sign into our calculator all at once. So we get 29 squared plus 24 squared minus 2 parentheses 29 parentheses 24 trig button cosine 101. And we get 1,682.61. And then we take the square root of that answer. And we get b is approximately 41.01. So now we can go over and fill it in for here. Plus 41.01 squared minus 2 times 29 times 41.01 cosine C. Okay, the problem when we're figuring out an angle is I have to put it in parts into my calculator. Oop, 24 squared. So I'm going to have to do each one of these separately. 24 squared, and then I'm going to have to do 29 squared plus 41.01 squared. And then I have to do this part. So I have to do each one separately. So first I'm going to go 24 squared gives me 576, which equals 29 squared plus 41.01 squared gives me 2,522.82 minus 2 times 29 times 41.01. Yep. We get 2,378.58, and that's cosine C. So then I have to get rid of this part next. So I have to go 576 minus 2,522.82. I'm going to get a negative answer, and that's okay. Negative 1946.82 equals negative 2,378.58 cosine C. And then I'm going to divide by that negative number. Divide by negative 2,378.58. And I get 0.8185 equals cosine C. And then I'm going to do the inverse cosine. Then I'm going to do inverse cosine. Of that number. And I get C is approximately 35 degrees. Okay, this seems like a lot, right? Like it was bad enough when I gave you the other one, when there's so many little things there. So what I'm going to tell you is if you want to find angles, there's a shorter way to do this. Okay? There's a shorter way to do this. So I'm going to zoom out just a little bit. And I'm going to show you the shorter way. There are 3 different ways. These angles are going to have to be written down. So if we're looking for C, we go cosine of negative 1 times C squared minus A squared minus B squared. all over negative 2AB. So we can put this, if we're looking for angle C, we can put this in our calculator all at once. So this would just mean cosine negative 1, and we're going to take C squared, so that's 24 squared, minus A squared, that's 29 squared, minus B squared, that's 41.01 squared, all over negative 2 times 29 times 41.01. And we can put this all on our calculator at once. So we hit trig button, cosine negative 1. We hit control divide. We hit control divide, and we put these in here. 24 squared minus 29 squared, minus 41.01 squared, all over negative 2 times 29 times 41.01. Okay, so I literally just took these. I have my stuff labeled. I plugged them in. I put it exactly into the calculator the exact same way, and much faster I come up with it. It's 35 degrees. Okay? Much faster. So it does mean that you need to know 2 different ways. You need to know 6 equations for a law of cosines. Okay? All right, I am going to stop there. I am going to put, I am going to write down, so this is for if you're finding C. If we're finding angle A, we're going to cosine of negative 1, and we're going to go A squared minus B squared minus C squared, all over negative 2 BC. And if we're finding angle B, I'm going to make sure you can see these, we're going to use cosine of negative 1, and we're going to use B squared minus C squared minus A squared, all over negative 2 AC. Okay? So those are other equations to find your angles. I am going to stop recording right now, though.